looking at the 3.3 task, features of functions. The very first example, there's a great video for you at the beginning of the formative. So if you're feeling confused, please watch that video. I think it will help. And the very first problem on the formative has been done for you. So I want to go over that problem with you to help you make sense of it. So the directions say, for each graph, determine if the relationship represents a function. So that's the first thing you're going to want to do. And then if it is a function, you're going to find those key features. So that's the whole point of this module, key features of the function. So those features include intervals there where the function is increasing, intervals where the function is decreasing, finding a maximum, finding a minimum, finding the intercepts, that's both the x and the y intercepts, finding the domain, which are the x values, and the range, which are the y values. And then end behavior just says what happens at the end. Does it go up? Does it go down? What's the pattern there? Or does it stop? So we're going to start with the intercepts. So I feel like that's was the first thing in the list. So the x-intercept is where does this function, where does the graph cross the x-axis? So remember, the x-axis is the horizontal axis, and it looks like it touches right there on the x-axis. So that is the point. An intercept is always an ordered pair. So I'm down here at the x-intercept. That is the point 4, 0. And in the x-intercept, y is always the 0. And then the y-intercept is where does the graph touch the y-axis? And so it looks like it touches just a little bit above 3. So I'm going to estimate that that's the point 0, 3.2. So notice that in the x-intercept, the y value is 0. It's what is x when y is 0. And the y-intercept is what is y when x is 0. So just, remember that those zeros are flipped. So we found our intercepts. Check, check. Let's look at the increasing and decreasing intervals. So when you're looking at this graph, when does it go up from left to right? So I'm going to do increasing in green, and I'm going to say, well, from here to here, my graph is going up. So that's an increasing interval. And so I did that in green. And here's a little trick that we're hoping to teach you. Since the point A is a closed dot, that means that that point is included in our function. And closed dots mean brackets. And so I'm going to put a bracket there. And then B, point B right here, is a closed dot. However, at point B, you're both increasing and decreasing at the same time, right? It's where you end your increase and you start your decrease, and it can't really be both. So instead of giving it a bracket, we're going to give it a parenthesis, which says it's changing directions at that point. So for the increasing interval, I'm going to say bracket, because that's the first point. The leftmost point is included. And that leftmost point is at -3. So it's increasing from -3 all the way until +1. And then I put a parenthesis here because that's when I'm changing directions. And so I'm not increasing anymore, but I'm also not decreasing. So it's a change of direction is what a parenthesis tells us. And then at that point, I'm switching from an increase to a decrease, right? I decrease the rest of the way. So the decreasing section is also starts with a parenthesis, right? Because it's kind of a shift. And that starts at +1, right? It starts right here at +1. And then I decrease all the way until I get to 4. And at 4, it's a closed circle. And I definitely stop at that point, so I'm going to put a bracket on that end. So that means my decreasing interval starts with a parenthesis, it ends with a bracket, and it stops at 4. So what I am saying with this notation is that this graph increases from when x is -3 all the way until it's +1. That's this whole section. And then I change directions and I start to decrease from that +1 all the way to 4. And then it ends at 4. That's what the bracket tells me. So we've done those two problems. Before we do our domain and range, let's do the maximum. So the maximum is the highest point possible. So you are just checking your graph, and how tall is it? Well, this graph has the maximum height is right here, which is a y value. It's a 4 on my y value. So I'm just going to write down the actual point. Where is this? What is the point where my graph is the tallest? And the maximum is the point 1, 4, right? That is how I went over 1 and up 4 to get to that point. And the minimum is just what you think. It's the lowest point on the graph. So when I'm looking at my graph, it looks like here is my low, right here. That's the bottom point that I get. So that is the point 4, 0. And it's totally okay that the lowest value, the minimum, is the same as the x-intercept. It won't always be. This is just find the lowest point on the graph and write it down as an ordered pair. And this is find the highest point on the graph and write it down as an ordered pair. So we've done all of the features of this function except for the domain and the range. So if you remember me being annoying and saying domain is your width. How wide is your graph? What are the x values? Oops, I meant to highlight that. What are the x values for this graph? So find the, remember x goes left and right, so find the leftmost point in this graph, which is right here. So my domain starts at 3, and 3 is a closed circle, so I'm going to give that a bracket. At 3 is where it's, or -3, sorry about that. So find the leftmost point, and then how far to the right does it go? It goes all the way to here. So I'm kind of measuring the width from there to there. If I'm cropping my picture, that's how wide it is. So from -3 to +4, and both of those are closed circles, so I'm going to do brackets. And then my range is measuring height. How tall is my graph? So that's cropping the height of my graph. So I'm going to find the lowest point, which we already did. The lowest point was down here at 0 on the x-axis, or sorry, on the y-axis. And my highest point is 4. So if you notice, I kind of drew an H, which is sort of like cropping your picture when you're doing that. So the range is y values instead of x values, because it's measuring the height. So it goes from 0 on the y-axis all the way up to 4 on the y-axis. And this point was a closed circle, and this point was a closed circle, so I'm putting brackets on both of those. So we're just looking for key features, and I think it's best to just do one thing at a time. If you notice now that I'm done, my graph looks kind of a hot mess. And that's okay, because it shows that you're thinking and you're physically understanding where each of these key features is on a graph. The second one, it says, the first thing I was supposed to do was decide if it's a function, right? And if you'll remember, a function is when it doesn't, no points on the graph stack on top of each other, nothing overlaps. But on this graph, if I'm doing that vertical line test, these 2 points overlap, these 2 points overlap. These 2 points overlap. Basically, everywhere on this graph has somewhere else where it's being overlapped with, except for probably right here. So this is not a function. And why? On the test, you have to give a reason. Why is it not a function? Because it does not pass the vertical line test. So if I drew vertical lines, which I did, there are places on this function where the vertical line touches 2 points at the same time, so it is not a function. And lastly, the very bottom asked you to do basically the same thing, but instead of a graph, which I like graphs, they're much easier because you can physically see everything, we're doing it on a table. So it says this table represents a discrete function, so if it was graphed, it would be just points, not connected, defined on the interval from 1 to 5. So that means that this function starts at 1, it ends at 5, and that's the end. If I were to graph this, it would just be points. They would not be connected because they're telling me that it's discrete. So for this problem, we're going to start with the domain and range because domain, if you'll remember, is all of the x values, right? So it's all of these. And in the top graph, when we did domain, we used interval notation because these brackets and parentheses say every possible number between -3 and 4 are included because it's continuous. But this one isn't continuous, it's discrete. So my domain is just going to be a list of numbers. So the domain includes 1, 2, 3, 4, 5. That's the domain. I can list the numbers because it's just points. There are not any other numbers in between those points that are included. The range is similar, right? The range is what are the y values? And remember, in f of x is the same as y, right? So our y values include, and this one is where it kind of gets tricky. Even though my table goes 4, 10, 5, 8, 3, we need to list our range in order from least to greatest. So I'm going to list it as 3, because that's my lowest number, 4, 5, 8, 10. So my domain is a list of numbers in the x-axis. My range is the list of numbers in the y-axis. Both go from least to greatest. Both are brackets because it's discrete and all of those points are included. So we did domain and range. X-intercept is where it's the x value when y is 0. So in our table, is there a place where y is 0? No. So that means that this graph doesn't touch the x-axis. So there is no x-intercept. None. The y-intercept is where it's the value of y when x is 0. So looking at my table, is there a place where x is 0? No. So that means that this graph doesn't touch the y-axis either. So that means there is no x-intercept and there is no y-intercept. So the minimum is going to be the lowest point. And if we're talking about height, we're talking about the y-axis. So what is the lowest y value? Hopefully you're saying, hey, it's 3. So the minimum is the point 5, 3. So even though 5 is the highest x value, it's not the highest point on my graph. 5 is the rightmost point on the graph, but 3 is the lowest point. So this is the point to graph it. I would go over 5 and down or up 3, but that's the lowest I would go. So this is my minimum, right? And then my maximum is the highest point. So we're looking for the largest y value. So look at our y values. Which one is the highest? Hopefully you said 10, right? So that would be my highest point on my graph, and that's the point 2, 10. Okay, so hopefully this was helpful to go over the examples. They have been worked out for you on the formative, and you're spending most of the class working on just this one function and identifying those features. Feel free to show your work by highlighting minimum, maximum, increase,